My mic was mute, Mike.
I noticed that. I was like, "Oh, trouble!"
Yeah, that's okay. You should have called off. You had one chance to call me off.
I'm like,
How are
"Oh
you?
my
How are you?
gosh!" I'm good. How are you?
But here, it looked like a winter today here in Melbourne. So we'll see how this ends the day. How's Sydney today?
It is a bit overcast today. Yeah, we're expecting some rain as well. So, yep,
Nice.
feels like summer's coming to an end. Sad.
You got vaccinated yet?
No, one day.
One
I'm
day
just
it's
gonna
gonna
get all
happen.
of them, right? I'm just like I can't handle the news. All these different these ones do this one. This is. I'm just gonna get them all. Like,
That's right.
let me know when you get shipment in.
Well done. Hey, let's get into this thing. Hey, welcome, guys. Hope you're all doing well. This is our last episode of the series. It's finale. So we're hoping to finish this with a blast. We'll see. And this is Rajesh, and we got Mike here. Mike's the actual influencer of and the YouTube influencer, I hope. Is that right, Mike?
Well, we were told like YouTube's not enough. We have to become LinkedIn influencers. Remember that?
Oh,
Yeah.
of course.
Yeah, we have to move on. Apparently, we're not. We need to be more professional, and we need to rise to the LinkedIn status. Yeah. So maybe we'll work on that.
Let's try our best. Let's try our best. Cool. What's happening on the other side? This is our last one. How do you want to wrap it up?
Yeah, well, it is pretty sad. I feel like, I don't want to end on a downer, but man, it's like, what am I going to do with life after today, our last episode? Like, how am I going to go on? I don't understand, Rajesh. I might need some counseling or something what am I gonna do, right? What am I gonna
do? Don't worry. I mean, there are plenty of things to do. We'll continue to do this. Don't worry about that. Look, before we start, I thought I'll give you a bit of a rundown on what happened in the last 3 episodes of this whole series. The first episode, we had a quick look into how to operate API management within an enterprise. The second episode, if I remember correctly, we looked into automating the control plane and the data plane, how to quite easily automate that using Terraform and Ansible. And the third episode, which is last week, we did show you how to actually onboard APIs via control plane and populate that into the data plane wherever it's deployed, whether it's a load balancer or an API gateway. We showed you how to easily configure that. In case if you guys missed the live stream in the past, please feel free to go back and watch those 3 episodes. It'll be a good story to actually continue to this finale of this series. I'll pass on to you, Mike. Show us what's the agenda today. What's the surprise is going to bring it to us?
The surprise. Oh man. All right. So sorry, I had the wrong slide up there. Those are the last 3 episodes that Rajesh was talking about. But thanks for the recap. Today is all about securing your APIs. So we're going to go through different technologies we have at our disposal, rate limiting, JOT authentication, validation. We're going to look at some WAF technology. So it should be a pretty exciting show on how to secure your API. I did want to mention, though, this is our last episode. And just as we're going through this episode, if you could keep it in the back of your mind and think about some other topics you might be interested to see in future episodes, we'd really appreciate that. If you enjoyed the show, let us know what you'd like to see next, and we'd be happy to keep going, see if our sponsors will sponsor us for maybe another season.
Yeah, it'll get renewed. Maybe.
I hope so. Fingers crossed. Well, I don't know what I'm gonna do, right? This could be the end of my career at NGINX.
Of course, yeah. It's great. What's next? Where should we start? You're going to actually give? You already talked about the agenda, if I'm not wrong.
You know what? I think these slides might have been just a bit out of order. So yeah, we covered the recap of the last shows. And then I think next we're going to talk about the importance of securing your APIs before I get into a demo, and then we say our sad goodbyes.
Yes, this API security thing is something which is currently when every business is trying to run their capabilities or even exposing data is everything is via API. So it has the security of those API, security of those capabilities become really eminent for any companies. So the pretty much the way it's being consumed, it's a different media. It's through your laptops, even to your mobile, it's to tablets, and the security actually comes from a very different originated from different tools and different devices. So it's quite important to apply right level of security for all like for common factors, common risk, what's appearing in the internet. Like if you want to the next, I think I captured the common attacks. There you go. It's running out of words. Thank you. So these are all the few common attacks you might see in the wild when you are trying to, consume an API. So some of them could be a SQL injection where they will, try to actually append certain SQL command to your API calls to get more information than what it is intended for. Cross-site scripting that actually happens at the time of login to actually hijack your cookies or sessions or tokens. The DDoS is the biggest problem, and it actually has, can be originated. Then now the attackers are really getting smart with that. The DDoS we have a history of actually bringing down a certain business because of this DDoS. And man in middle is really like a bit more technical, where actually between the consumer and the provider, someone actually tried to steal it just by mimicking the consumer and get the information and use the data on behalf of the consumer and misuse it. So which quite often happens. The credential stuffing is also quite interesting, but it is more relevant to the identity side of the world. I believe, if I'm not wrong, Mike is going to show at least 3 or 4 of these common attacks, how to mitigate this using NGINX quite easily through the controller. So you don't have to worry about these, the common attacks happens in the wild. Sorry.
Yeah. Fantastic. All right. Yeah, of course, we can't show the problems and not provide the solutions. So got to round out the whole episode. So going from where we left off, right? With our labs, with our demo environment, we've slowly been building through the episodes, deploying our NGINX controller and our NGINX Plus instances, pushing our configuration out for our 2 test apps. And if you remember, we did one application, the J service application, which was an API that provided Jeopardy questions. We deployed that using NGINX Controller's ADC. So it's an application delivery controller. Is that what it stands for, Rajesh?
No, application. Yeah, it is.
I feel like I should know that. Anyway, and the second one is our REST countries API, where you can query the API to find information on different countries, languages spoken, currencies, and all kinds of cool stuff. And we used NGINX Controller's API manager to deploy that. So, and then the third bit we deployed was that dev portal for our REST countries. So that's a quick little overview of what we have deployed. If we go in here, today we're going to, if we recall this image from last week, we talked about the platform and the infrastructure, and we mainly spent last week's time in the services section. Well, this week we're going to spend our time in the security section. So we're going to deploy an identity provider for our JOT validation. We're going to deploy some rate limiting for our DDoS protection. And then towards the end in the demo, we're going to deploy a web application firewall that'll allow us to provide security for some of those other attacks that Rajesh just mentioned. So let's go ahead and switch over to our environment. And we'll just jump in here. You can see I'm already in the services tab of our NGINX controller. So I just wanted to just to start with where we were at last week. So we have our two applications configured here, our JService application, our REST countries application. We've gone in and we've configured a single component for our JServices. So we've configured our endpoint. We've configured our SSL certificate, our backend workload groups. So all that is still configured. We went in and we published our REST countries open API spec, where we did a configuration of API management by using our open API spec. And then you can see here, we have our applications all running. So this is our REST countries example here. We're searching for all the countries with United in the name. And as you recall, last time I changed that to Oz, but of course that changed for Australia, no longer in America. And then also our JService application where we did, that's the wrong demo. I was testing the environment, of course, where we queried for a Jeopardy question there to show that it's all working. And if we go back,
so, Mike, I assume you didn't apply any security there. That's good. I just wanted to double check you didn't, trick us by applying that upfront.
That's a fair point. That's a fair point, and I should show that. Thank you, Rajesh. Rajesh, as always, keep me honest. So you can see here, it's even written no security settings, right? So we've got our API. So we're going to start with the REST countries API, and you can see so far in the API manager, I have no security settings defined. So let's go ahead and get started with JOT validation.
Oh, now, that's my favorite.
What's that?
That's my favorite area.
Oh, is it?
Identity and yes. Show me.
So yeah, so the first thing we have to do for JOT validation is we have to define an identity provider. Now, identity provider is where we provide information so that we can validate JSON web tokens that are coming in with our HTTP requests. So oftentimes we need to define a type. We need to define a JSON web key set that tells APIM the public key that can be used to determine if the hash is correct for the JSON web token. So we can do this by going through the GUI. But
I wouldn't appreciate that.
I know. I've been scolded before in previous episodes. But we can't do it. We can't use the GUI, right?
You can use the GUI. It's just actually it's good to see it. It's okay. These are all the components available. Visualize it. That's great. But I hope I can automate all of this one. If I'm creating an identity provider to make sure that I've been authenticating all my requests against an IDP, that means it needs to be automated end to end. There you go. This is the screen. I like it. When I see amazing, the rest.
Like you read my mind. How did you know? Amazing. All right, so it just so happens that I've got the API call to add an identity provider. So how lucky is that? So we can see here, I've gone through, I've given it a name. I've shown the environment that we're going to add it to. So the prod environment, if you remember, that's where we configured our REST countries app. And I've decided we're going to do a JOT provider, so JWT, JSON Web Token. And we're going to provide here, this is our JSON Web Token key set. So all this information is provided here and all the ways we're going to use it. And just as a quick side note, I just want to show you for your own testing purposes, I found this fantastic site here where you can go and create your ticket. So you find your algorithm, your key size and all that. So I just thought I'd mention that MK, JWK. Make it easier when you're testing in your environment. But if we go back to there and we do our post, which of course we always have to log into the controller first to get our session cookie, our authentication, then we can go and create our identity provider and add our key. So we'll just send that. We can see it's been 202 accepted. And if we just go back to that pretty GUI and show that our identity provider has been added, we can see now that that key information has been updated in here.
Hey, Mike, if you don't mind, can I throw my 2 cents into this. This is good, right? I mean, here for the demo purpose and stuff, you have used the JWK key and you copied it here by using that fancy website. It looks really great. However, in customers in production environment, they won't be using this, give or take, most of the times. This is one way of doing it. When they actually, this is, I noticed you went for the highest algorithm here, RS512. Mostly they used to go for RS256 or even RS512, where they have that asymmetric keys where you have private key and the public key. So the way how IDP works is whenever a token is minted, it tend to go and sign that request using the private key, which it never shares that private key externally. So the IDP is completely, centralized somewhere. Once the token is sent to the client, maybe a mobile app, maybe a web app, and then the token actually get presented via API gateway to the microservice. The gateway tend to actually verify whether the token is tampered or not. So to do that, you need to have the public key. And the public key tend to get rotated every 3 months. With this particular approach, what we are doing, rotating is easier if the IDP, the person who is managing the IDP and the gateway is the same person. Most of the times it's not the same. It will be 2 different teams and they have their own life cycle. Some companies tend to rotate those public private key combination every 1 month, sometimes every 3 months. So in that particular aspects, it's better to use the URL option, where you can give the public URL, where the IDP tends to actually give you the public key and the public key get verified. So whenever the IDP gets rotated, NGINX Plus is smart enough to go and pick that public key every time when there is a rotation happening. So just I thought that's another option which all of us should know. Make sense?
It definitely seems like it'd be more secure than the static key that I put in here, right?
Yes, it also for operational purpose as well. Yes, it will be, because if some customers wanted to do it every year, some customers wanted to do it every 3 months. If you take Google IDP, they do it every 3 months, which is, little often.
Do you know? I know this is a side question here. How often, when you put the URL in there, how often it gets checked? Do you know?
So what happens is, for the first time when the request comes in, it goes and actually caches the key. As you know, NGINX is pretty popular for its caching mechanism. It goes and caches the public key. When that is the public, when the NGINX Plus realize that it is not the same public key, we can use it to assert the token, it automatically makes a call. So it doesn't actually, it is not counted or anything. It's mostly when the public key fails to verify, it makes another call to get the latest public key. So that way, it always get the latest key every time if there is the public key private key rotation happens. Because if you look into certain places, they tend to have the N-1 kind of approach, where they have the previous private key and public key combination under the new key, because sometimes tokens tend to run for a longer period, probably for a day, even for a month sometimes. So they may have both the keys at the same time.
Cool. All right.
Sorry, it's not. I hope it's not over the head, but feel free to ask me anything on this one. This is the one bit I know a little bit better.
Cool. All right. Well, thanks. So we define that identity provider, and then of course, like I showed you earlier, we need to define that identity provider. We need to attach it to our API. So we're going to go down to, so we created the identity provider. And now we need to add that identity provider to the component. So if we go into this next put here, we can see we're going to go modify our component, RC main component. So you'll see before, if I go back to the GUI here, I can show you that I showed at the beginning of our presentation here, the API that's been published has no security settings, right? And if we go into there, of course, I'm not going to do it. I'm going to say there's no authentication here. If we go back to the Postman request, we can go through here and see we have all of our standard configurations that have been in there. So load balancing method, the URIs we're going to use, right? DNS discovery, all that information is here. All of our endpoints, And if we keep scrolling down, we'll see here that there's a new section that we're adding in this call where we're adding security, right? So security, identity provider reference, and you'll notice the name of that matches the one that was just posted previously. We're defining here that we're going to use JOT client authentication and the key location. So it's going to be a bearer token in a authentication header. And then, and so that's the information we're providing. So we're going to send that off to the controller. We'll get back our 202 accepted. And if we go back to the GUI to show what's been done, we will just go in here and see if that refreshes. Nope, we'll cancel that. Back in here, and we'll look at a routing, and we can see now authentication is here. So we can see that it's gone in and it's added that authentication and it's added that token. And if we look further in the configurations, you can see credential location is defined as bearer, and the identity provider that we provided is there. So if we go back and show a really exciting example of how that works, we can see here we have a call in Postman here for our REST countries example.com API that we configured. And that same request that I made earlier, if we make it again here on Firefox, you can see we get back our 401 unauthorized. Sorry, 401 authorization required. That's a mouthful. But if we send the request here, I can modify the authorization header. I said authentication earlier, didn't I? Oof. Where are we at? We're supposed to have my back here.
That's one of the main reason we have shortened that auth in and auth z. So.
Okay. So I added the bearer token, and we can send that off, and we can see that we get our same united response back, and the authentication is working. Now, if we look at this token,
I wanted to do that, Mike. I really wanted to inspect the token. How does it look like?
Well, you know what? You are in for a treat.
I just wanted to, because as I said, this is one place which I really wanted to, see through it.
It is pretty exciting, like learning about the JOTs and the three different parts, the header and the payload and the signatures. And it's definitely, I think it's a really cool way to do authentication, personally. It's just me.
And I believe the website which you showed, that also helps you to do this quite quickly, isn't it?
Yes. So the JOT.io debugger allows you to take that same token. So I just cut and pasted it out of that header that you saw just defined in Postman, and I drop it in here, and you can see that it takes the base64 encoded header and decodes it, tells me the signature algorithm that was selected, so RS512, the key ID that's defined here, which is basically just a SHA-256 hash of the token, and then the type. So it's a JOT token. So we're just checking the signature. We're not doing a full JSON web encrypted token. And then the payload has the information about the authentications, about the authorization for the client using the token. So you can see here, we've just got 4 claims. Each one of these in the payload is a claim. You can define more, you can define less. But we've gone through here and we've defined a subject. So it's just a random string of numbers, name as an example, user's name. And then admin, we've got admin is false. And then we've got the time at which the token was created. So
I got a question around that, Mike, if it's okay with you. Yeah, I saw you used a claim called admin true false. Like, how does it work? Why do I need that that particular claim over there?
That is an amazing question, Rajesh. Let's talk about conditional access. So if we go back to our controller definition here, you see, remember in this GUI here, there was this conditional access checkbox that we had, and that allows us to interrogate the values in that payload. So after we validate the token is good, signature matches, we can go in and look at particular claims in that token, and we can call them out and say, allow when, JOT claim, and we can put admin, right? Equals, right? So you can see all the options that we have here. Equals true, right? And then the failure response if it doesn't, right? So we can put in these conditions here to further interrogate that JOT token. So I've got it all configured here. I'm sorry, Rajesh. I know it's a massive faux pas, but I'm just going to hit submit. because there's no point in sending the postman request when I already have it configured there. So we can see now we've got conditional access. We'll hit that submit, and then we can go in and remember that token. This token here that we were using has a false. So if we send that request again in Postman, that one I just did here, we'll send it again, and you can see I now get that 403 forbidden because our admin claim says false. But if we go in and we change that token to a token that is, say, looks like this one. Oops. Yep, this token here. I'll just copy that. We can go back to our .io debugger.
Yeah, I would love to see that. Yes.
Yeah, and I'll just paste that in there, and you can see now the token's been updated. Admin equals true. So if we send a request with this token, and we'll go down here, have it all created, admin equals true. You can see in the headers here, we've got the new bearer token in there. And if I send that, then we should see the 200 OK instead of the 403. So it's done that conditional access. It's validated that claim. And then it's conditionally allowed the user to access the API.
Yeah, that's good. This is something which quite heavily used. Some of the customers tend to go and use role attributes to verify like what level of access you have, and even they tend to actually throw the error before forwarding that to the upstream microservice. It's kind of a fine level authorization, but I have seen a lot of customers actually tend to apply this level of RBAC, conditional access, right in the gateway, so they don't have to bombard their backend. For example, let's say only the admins can have access to do a delete operation. So, or even admin can have access to create and delete. Then we could actually literally write a condition over there saying that if the role is admin, then let them to do it. If not, they do not have access to delete or create, which is quite heavily. So this is good. So now I know that I can do this in NGINX Plus quite easily. So it's good to know that I can configure via controller is much more easier now. So I don't have to deal with all those NGINX Plus directives. Instead, do it in a declarative way. That's good to know.
Yeah, it's pretty neat. I remember I think we had a customer that wanted to add JOT validation in front of their web app. They validated the JOT token using NGINX, and then they pulled one of the claims out and they actually put it into a header for the backend system to push that authentication because the backend didn't support JOT, and that was how they got their authentication.
Yes, that is popular as well. Yeah, because
it's a real neat use case.
Yeah, it's some of the legacy applications which is written in the past. They don't have those JOT support or this OIDC support. So what they tend to do is instead of actually relying on the token claims, they need that information to make a decision backend service. So the only way to do that is to rely on gateway to do that. So in this particular access, what they can do is once it's validated, if it's true, then it can actually populate that as part of the header. And the application or the backend upstream service could actually handle that by reading out that from the service. If you ask me, it's not a recommended way, as you know well. It's not a recommended way, but we do not have a choice when the upstream services are pretty old. They can't actually change the way how the modern application works. So unfortunately, it's kind of a tactical fix we tend to actually recommend now and then.
Yeah, cool. All right, well, so that is JOT validation. Let's jump back into our second security feature we can add, and that is rate limiting. So if we go back to our routing here, we see we got conditional access, we got authentication, and if we go in here and we look at rate limiting, we can now, based on a key value of our choosing, in the controller API management.
APIM.
I'm stumbling over my words all of a sudden. I thought that beer would help for this presentation.
Don't feel too much, mate. It's definitely we'll come back to the next series. I think you're stammering because this is your last episode. Please don't.
I'm tearing up a bit. Yeah. So we can configure our rate limiting, and of course these are the options that you have here, but I've got a beautiful little postman that we can review. And we can see here, again, we configure it in the component. And if you remember, I showed that section of the JSON blob here where security starts. So security, there you go. Security starts right here, line 66. Hopefully that's viewable. And you can see underneath here, rate limits have been defined. So policy one's being created at a rate of 10 requests per minute. And when it's exceeded those 10 requests per minute, it returns a status code of 429, which is says the server saying, hey, I'm busy. And we're looking at the request URI path. So if you make the same exact request 10 times in a minute, it'll send 429. If you change that path on the end of the URI, send it again, it'll work up to 10 times and then block you for a minute. So let's go ahead and apply this. And let's test it out. So if we go back to our admin true request and we'll do a send here, you say it worked, 200, okay. I got 429 too many requests because it was keeping track of, well, Rajesh, why did I get 429 so quickly?
It's because the rate limiting algorithm what NGINX uses is really unique. So in this case, I noticed you gave 10 requests per minute or 12 requests per minute. So let's assume hypothetically it's a 12 requests per minute. Then NGINX is smart enough to let you to access only one request for every 5 seconds. So it divides the number of requests and within the minute, and then it let you to actually play it. So 12 into 5, 60. That means you can play first request and you have to wait for the next 5 seconds to play the second request. So it's smart enough to actually do that, the divide between this one. So with this way, you don't have to, you won't be bombarding your upstream services pretty badly if it's if you don't want to. But by the same time, you can even apply a bit of a leeway if you really want to, let some of the requests to go through. So this is pretty unique to NGINX when you apply this kind of a rate limiting.
Okay, cool.
I also noticed that you configured that to send a 429. That is really nice because in HTTP mode, it is 429 is the too many requests thing. So which is good.
It looks like they give you a whole list here. You could probably pick everyone. So 429 would be the recommended.
That is right, yeah, because it is the one which has actually come out of the spec HTTP spec, but there are customers who have used different HTTP codes in the past. So just to support their thing, we have all the HTTP codes in place, but it's highly recommended to use 429.
Okay, cool. All right. So that concludes the rate limiting and the JOT validation demo. And now we're going to move on to web application firewall. So we're going to switch applications and we're going to jump and start using our JA services applications, so our Jeopardy questions. So you can see we've gone through and we've already configured our components in the class. And one thing I wanted to bring your attention to, if we go in and edit that component, is the security tab. Now you can see in the security tab here is where we enable our web application firewall. For those of you not aware, our web application firewall is one of our newer products at NGINX. It is our NGINX App Protect, and it is based on F5's Application Security Manager or Advanced WAF product. They've taken that, turned it into a dynamic module, which you can bolt on to any of your NGINX Plus instances. So whether they're VMs, containers, ingress controllers, you can add a WAF protection to those products. So with the API management functionality and controller, you can also turn on that WAF if your NGINX Plus instance was built and with that dynamic module at runtime. So with that, we'll turn on the WAF. We've got it on here, and we can go back and we can do our standard JSON request here. So we're looking at a random request. We make a call to the API. We get our question, our Jeopardy question back, rows, all the information on that. But one thing, we need to check for is maybe, instead of somebody using the count parameter, maybe somebody's going to throw in a script, right? A script tag. So now we can watch for these common attacks. So part of the OWASP top 10. And with the basic everyday policy, so we have a day 0 policy that comes with it. And this is, of course, the default block page. But if I could just show you our default policy. So this policy here, these 6 lines, it looks like, is the default policy that comes with every NGINX App Protect instance, which is really handy because it allows you to have that day 1 protection. So as soon as you install it, you put this base template in, and it provides protection against, like I said, the OWASP top 10. It has really highly tuned signatures to reduce those false positives. And so it allows you to just really hit the ground running with NGINX App Protect. And of course, from here, we'll just build more and more. And so I'll show that, of course, in the next demo. We'll add a bit more, some more features. But as this policy is added here, we can go back. And if we send just a few more requests, we can see that support IDs changing. And if we go back into our component, we'll go back to that app screen, look at that JService app. One of the other features that we gain here with Controller is the security analytics. So we can see the number of rejected requests coming through, the percentage versus valid requests. We can get some nice, pretty graphs. You know, management loves to see those graphs. That's why they're included in every single GUI product. And so it's really a good source of information to determine maybe why your website's running slow. And further down, you can drill down into the security events that you're seeing. So now we're logging the rejected events. And if we go and just click on the top one here, which is hopefully the one I did, we can go and get all the information about the environment, the app, signature IDs that were triggered in case they happen to be false positives. We can take those signature IDs out, add it to the configuration and say, you know what, allow those signature IDs. And then if we go down even further, we can see the request information that was collected. And as you can see here, here is my script tag that I added in here in the request. So I can see exactly why the request was blocked, the remote IP address, all kinds of good information on the attack. And then I can also not only look at the logs here in Controller, but I can also use data forwarders to forward that information to maybe a local Splunk instance or whatever SIEM product you might be using to take that information, correlate it with other pieces of equipment within your environment to maybe see a whole attack or maybe find somebody who's doing some type of reconnaissance on your network.
Yeah, that's cool. So what you demoed is a cross-site scripting mitigation.
That was that one, that example there. I'm sure we could find some SQL attacks and all kinds of good stuff that would also be blocked.
Yep.
But I did want, you know, we're all with spicy demos here. And so keeping it spicy, did a quick script attack. But now we're going to leave the controller and we're going to move so I can show you a few features that are easier to show with configuration of the command line. So I touched on before the base policy that comes with NGINX App Protect for your day 1 protection. And I just want to highlight, we have a few other default policies that come with NGINX App Protect. And if we just have a quick look at our NGINX App Protect and we just do an ls in our SE NGINX directory, if you're familiar with NGINX, you'll know that this directory is where NGINX stores its configuration. So you can see that nginx.conf file is there. Which is configured by Controller in this particular instance. But you can see we not only this instance not only came with the NGINX default policy, but also came with 2 other policies. So the NGINX strict policy, which has a lot of functions and features turned on as an example of the things that you can add. But the policy we're going to talk about now, which is, I think, one of the coolest features of NGINX App Protect myself, I mean, maybe I'm just biased, no idea, is the NGINX API security policy. Now, why this one is cool is because you can take an open API spec that you've created for your API. And if you remember from our last episode, we used an open API spec for the REST countries API. That's how we deployed it. We used that design that we built in that Swagger editor, and we use that to configure our REST countries application. Well, for this example here, I went and created the equivalent open API spec for our JServices application. And so I've gone through here, you can see on your screen, and defined some metadata around our API, as well as defined 4 paths. So we got API clues, we've got API random, and then 2 others. And then within each of those paths, we've defined parameters. And we've gone through and we said, okay, if we go through in the query string, we're going to put the name value, and that value is going to represent the clues value in US dollars, and it has to be an integer, right? And then if you go down to the API random, you can see, okay, we've got a parameter that is count, defined here on line 65. It should also be in the query string. It's the number of clues to return. So not only is that Swagger definition providing good information for documentation and endpoints, but it also tells you what the parameters are expected to be, which is pretty neat. So with all that information defined, wouldn't it be a great idea if you could just take that and create your security policy based on that, which is what we're going to do now. So if we look at that NGINX API security policy that I pointed out, you can see it starts here at the top with the policy template NGINX base. So that means it's starting with that base day one policy that I mentioned before, and then it's adding some features and functionality on top of it. And so what it's gone and done is added in the block settings here violations, right? So mandatory request body is missing, illegal parameter location. So it's added a lot of validations, or sorry, a lot of violations that validate the HTTP requests that are coming in, and using the information from the Open API spec to make those validations. So what it's going to do is, for example, a legal parameter, right? It's going to go and validate that when I put that, use that count parameter, that it's an integer, right? So what we've done here is we've gone and configured, and the only thing we needed to add to the policy is the file name here, which defines that Open API spec. Sorry.
All right, Mike. I told you, don't. Yep. Don't worry. We'll definitely come back to the next series.
So I put that Open API spec in there, and then if we just go back to our instance here, we'll just go ahead and in this case we will modify our nginx.conf. And we're going to add in here this policy. We're going to change the policy that's currently in there for this policy here. So if we go down to the end, we can see in this line here, we have an app protect policy file directive. And in here right now, we have the file that was configured by controller. And it uses the NAT block default policy. So that was that that default policy that I mentioned for that day one policy, if you will. And if we just change that to the etc NGINX directory, and we put the name of that file there, we can just save that. And then we can do our NGINX. We'll just test it real quick, make sure I didn't do an error. And hopefully I didn't do an error, but I did forget my sudo there. So it'll check the files, it'll check the syntax, make sure that it's going to work with our NGINX instance. And while it's doing that, I'm going to get more water. We can see the file is successful.
Looks
and we'll
good.
just do, get your dish.
Hey, Mike, I also saw in your page where it actually says the block mode is true. So you can run on both block mode and non-blocking mode, which is good.
Right, yeah. So we support transparent. We support alerting. So if you wanted to not have it in block, and you know what else I forgot to mention too? If we look at that policy real quick one more time, I did update the block page. And the reason for that was because since it's an API and we're going to make API calls, I wanted the block page to not be a pretty web page like you saw here, but instead I wanted it to be a nice JSON response, right? So that our API can consume it. So then after that policy is applied, if I go back to Postman here, I can make our clean request, and you can see that it comes through with answers here because it's a legitimate request. You see my count equals 2. If I go in and I make that script request again, so you can show that that base policy is still in effect, and we can see our pretty JSON response there. So with the status support ID, we can also go in here and we can modify the count. So if you remember, the count's defined as an integer. So if it's 1, it works properly. But if I put an X in there and we send that, we can see I get another block page, right?
That's cool.
Yeah, so we can see that, and you know what? I did forget to demo it before, but when you don't have the WAF in there, it comes back with a 500 error, which gives you a bit of information in your headers as to the service that's being used and that type of thing. So it is definitely a good idea to stop that error from providing information about your application.
Yeah, that definitely brings information about your upstream server, and it's common if you don't have a right level of check in your gateway to mitigate this problem, which is good. It's great, Mike. It's almost we're closer to we actually a minute past, I believe. So this looks great. I think we could conclude the webinar. But do you think we should take a few questions as well?
Oh, we should definitely do that. Yes, for sure.
Any advice on how to best handle short key rotation and key management? Oh, okay. So this is if you are using the right IDP, the IDPs tend to actually handle this by itself, so you don't have to worry. In some cases, customers tend to write their own IDPs. Then yeah, the best way of actually doing that is doing frequently, and most importantly, try to follow what OpenID Connect specification have dictated you to do it, where you actually use the private key to sign it and publish the public key, where the gateways or even the APIs can easily access it, which is available in the internet. And gateways like NGINX can automatically bring those API the public key and verify the token on the fly without even you have to go and do anything manually. So that's definitely something which we highly recommend people to do, it not to hard code the keys within the gateway or in the application. Better to host it as part of your IDP and rotate it. We'll move on to the next. Just the right signatures came out. Okay, this is again it's more an identity security question. So in this case, I think the predominantly the one what is used is RS-256 or even RS-512, which actually supports this private key public key combination, where you go and use the asymmetric key combination. The other one which I have seen in the past, which is not much useful these days, is HS256, where you actually use a shared key and do it. But it is good for internal API calls, internal calls between APIs or services, but it never recommended for external services. So if you have to choose the right signature scheme, then I would prefer to go with any RS-based 256 or 502 kind of signature scheme. I think, Mike, we are already out of time. Maybe we'll take this as a last question, Mike. Are we using NGINX Controller here? Mike, go for it.
We are not. These, so if you might recall from our Automate episode, I think it's episode 2, I built all this in the Google Cloud environment using virtual machines. And it was a bit more of a challenge to do the virtual machines. I know Kubernetes would have been way easier with a nice manifest and just deployed NGINX Controller and the apps. But I think I wanted to automate VMs just to make it a bit more interesting. And it also got some nice Terraform in there for some infrastructure deployment. Let us talk about infrastructure deployments and configuration of the servers using Ansible and all that kind of stuff. So no NGINX Controller here, but WAF, I mentioned, is supported on NGINX Controller. So that is something we could do there in the future. Maybe that's an idea for a next episode, right?
So just to add on to that particular one, Mike, even if you use the NGINX Controller, we can achieve everything what Mike actually did it today. So it's pretty much you can do all those WAF policies, authentication, authorization, rate limiting, everything can be applied in the NGINX Controller as well, which is predominantly in the Kubernetes side of the world. What Mike showed, even Mike actually published that code in GitHub, which is part of episode 2, I believe, where you can go and get that GitHub location where you can pretty much spin up this environment on your own in GCP for now. That concludes
Oh wait, we got
Thank
one
you.
more. We gotta make sure. You know, how does everybody get a hold of us, Rajesh?
Okay. Your LinkedIn ID is really fancy, Mike. I quite like it.
You know, I saw that and I'm like, you know, gosh, I should go do something about that. That looks horrible. And then I completely forgot. You know, so it is
Hey,
that right
guy.
now.
Yeah. Hey, feel free to actually toss an idea. Like if you want to see some kind of live stream in the future, please let us know. We'd love to hear from you. If you want to reach us, that is there. You can reach us anytime. And if you have any ideas, or if you have or like what you wanted to see for the next live stream, ping us. We'll get back to you.
Keep us employed.
Thank you, Mike. Thank you, everyone. See you also.